Chapter P.3 Integer Exponents and Scientific Notation, Day 1. Exponents are used when a number is multiplied by itself numerous times. Then the number can be written in exponential form. For example, if we have 3 times 3 times 3 times 3 times 3, because there are 5 3's, we can write this as 3 with an exponent of 5. The 3 is the base number, the 5 is the exponent. Some special cases of exponents are when we have an exponent of 0, like a to the 0, or any number to the 0 equals 1, as long as the base number is not equal to 0. And then negative exponents, if we have a to the negative n, that negative exponent causes a reciprocal effect on the answer, and you get 1 over a to the n. Again, a cannot equal 0. So, for example, let's just look at this. Exponent of 0. I could have negative 45 to the 0 power. That's going to equal 1. I could have 10,053 to the 0 power. 10,053 to the 0 power. That is still equal to 1. No matter what number, as long as your exponent on the entire number is 0, your answer is 1. If you have a negative exponent, 5 to the negative third, that is 1 over 5 to the third. That's what I mean by reciprocal. So this is a whole number. The reciprocal would be 1 over that number. Once you create the reciprocal, the negative goes away. I could have 1/5 to the negative 2, and then that reciprocal of 1/5 would be 5 squared. So that's what the negative exponent does. All right, let's look at some other examples here. I'm going to put this in boxes just like we have it in our notes. So now we have boxes to separate these examples. So for example, again, like I said up above, I have a number to the 0 power, and that's going to equal 1. If I have a fraction to the 0 power, that is going to be equal to 1. If I have 5 to the negative first, that is 1/5. If I have a fraction with a negative exponent, that's going to be the reciprocal. The reciprocal of a fraction is to say put the top on the bottom and the bottom on top. So you're just switching these. So in reality, you take whatever number you have here under 1, but yeah, the reciprocal is 7 over 4. And with a exponent of -1, my exponent now is +1. If I have -2 to the negative third, I have 1 over -2 to the +3 exponent. A negative number on the outside, or a negative symbol on the outside, does not cause any change in the way your answer looks, other than creating a negative value to your answer. And we have to take -2 to the third power, which is 1 over, well, -8. -2 to the third power is -8. So our fraction becomes 1 over -8, which is just -1/8. If I have 2/3 to the -2nd, again, I have a negative exponent, so I'm going to be taking the reciprocal of 2/3, which is 3/2. And going from our fraction up here, we're going to get 3/2 to the second power. We have to distribute that exponent of 2 to both the 3 and the 2. So we get 3/2 and 2 to the second. Or not, sorry, 3/2. 3 squared and 2 squared. 3 squared is 9, 2 squared is 4. our final answer would be 9/4. So just kind of going over that again, if you have 2/3, put that, 1/2 to the second. If you have a number divided by a fraction, um, especially 1 over a fraction, basically you take the reciprocal of your fraction 2/3 and you have 2/3. So really you could kind of ignore this step if you know the reciprocal value of 2/3 is 3/2. So it kind of could be a little confusing. So reciprocal gives you 3/2 to the positive second power, 3 to the second power, and 2 to the second power. You get 9/4. These are the laws of exponents. There are 7 of them. The first one is when you multiply two base numbers that are the same with exponents. So a to the n times a to the m. A and m are just numbers, variables. If I have a to the n times a to the m, I am adding those exponents, n plus m. And therefore, an example of that would be x to the third times x to the fifth. I have a common base number. I'm going to add these exponents. So 3 plus 5 to get 8. My final answer would be x to the 8th. If I am dividing, I have common base values. I am going to subtract my exponents. Top minus the bottom. So a to the m over a to the n is a to the m minus n. So an example, if I have 3 to the 7th over 3 to the 3rd, I am going to have 7 minus 3. So 3 to the 7 minus 3, which is 4. So 3 to the 4th, which is 81. Now, if I have 3 to the 3rd over 3 to the 7th, okay, following this rule, I would have 3 to the 3 minus 7, which would be 3 to the negative 4. And with that negative exponent, we know that it's going to be 1 over 3 to the 4th. Looks like a 9. Okay, which would be 1 over 81. So, same kind of thing. If the bottom number is larger, you can subtract. It becomes a negative exponent. And then just make sure you get the reciprocal value, apply the negative value of the exponent. Law number 3, power of a power. If I have some number with an exponent and then raised to another exponent, think about distribution. I am taking this n and it's going to be distributed into anything that's inside here. When you distribute, what do? You multiply. So when I have to distribute that exponent from the outside to the inside, I am going to multiply those, and I have m times n. So an example would be y to the 3rd to the 4th power. I am taking that 4 and I'm going to distribute and multiply by all exponents that might be on the inside, and I would get 3 times 4, which is 12, so y to the 12th. Fourth law, I have two values on the inside being multiplied, so separate different values on the inside affected by an exponent on the outside. So these can have exponents other than 1, but regardless, you are going to distribute and multiply that exponent from the outside and distribute and affect all the exponents on the inside. So if I have a times b to the n power, I'm going to get a to the n and b to the n, not m here, so that's n. It's a typo. So an example of that, if I have x squared times y, all to the 5th power. So that 5 is going to get multiplied by the exponent of 2, and the 5 is going to go and affect that y value also. So I have 2 times 5. As you can see, x to the 2nd times 5 is going to give me that 10. So x to the 10th. and then the 5 is going to go also to the y to get y to the 5th for my final answer there. Up there I had y to the 12th. If I am dividing, same kind of thing. When I'm multiplying up here, that n is going to go and affect both of these, a to the n and b to the n. So I get a to the n over b to the n. So an example, if I have m over n quantity squared, I'm going to end up with m squared and n squared. Similarly, if I had m to the third over n to the 5th, and all of this was to the 4th power, I'm going to distribute that 4 to both exponents. Again, because I'm distributing into the parentheses from the outside, I am multiplying these, which I get m to the 12th over n. 5 times 4 is 20, so n to the 20th. And that would be my answer for that. The 6th law is if I have a negative exponent on a fraction, that fraction just flips. We talked about that, where you have the reciprocal. So a over b now is b over a. That negative goes away. And then I have an exponent on the outside of parentheses, and it gets distributed into both components on the inside, so b to the n and a to the n. So an example of that would be 3/4 to the negative 2nd power. I'm going to flip that fraction to be the reciprocal, to be 4 over 3 to the positive 2. And I'm going to distribute that 2 to the 4 and the 3. I get 4 squared over 3 squared to get 16 over 9. If I have law number 7, I have a negative exponent on the top of a fraction and a negative exponent on the bottom. This is really just showing you if I have a negative on the top, it gets moved down to the bottom of a fraction. And if you have other positive exponents, they are going to stay either on top or stay on the bottom. But if I have a negative exponent on the top, it's going to go down to the bottom and become a positive exponent. If I have a negative exponent on the bottom, it's going to go to the top and become a positive exponent. So in this example, I have x to the negative 5th. That goes down to become positive x to the 5th in the denominator. I have y to the negative 2 in the denominator. It's going to go up to the top to be y to the positive 2. So I have y squared over x to the 5th. Let's throw in a couple positive exponents. If I have x to the negative 5th and not y. If I have x to the negative 5th and y, gosh darn it, z is what I'm trying to write. So if I have x to the negative 5th and z squared over y to the negative 2. So that x to the negative 5 is going to go down, and the y to the negative 2 is going to go up. But the z squared is going to stay there. It's not going to move. So I will get x and x to the 5th in the denominator, and y squared goes in the numerator along with the z squared. So y squared z squared over x to the 5th would be my final answer for that example once I got that written out correctly. Okay, some examples. So here I show you two different possibilities with a 0 exponent. Notice the difference. I have parentheses around the negative 3. Over here in example number 2, I do not have parentheses. When I have the parentheses around the negative, I am taking an exponent of 0, affecting this as a negative 3. I'm affecting the entire value of this number, and I am going to end up with a positive 1. In this second example, I do not have parentheses around that negative value. Therefore, this is the negative value of 3 to the 0 power. It's almost writing it like this. Negative value of 3 to the 0. Okay, and that's going to be negative 1 for my answer. Let's look at this example. 5 squared times 1/5 to the 3rd. Okay, well, this 3 on the outside is going to distribute and affect both of those. I get 5 squared times 1 to the third over 5 to the third. 1 to the third is just 1, so I really don't need to write that exponent up there. So let me clean this up a little bit. 5 squared times 1 over 5 to the third. Now I have a whole number here, and I'm going to leave it as 5 squared and not change it to 25. But anytime I have a whole number times a fraction, it gets multiplied by the numerator only. So I have 5 squared over 5 to the third. And now this is like the example where I have to subtract. So I have 5 to the second minus the third, 2 minus 3, which is 5 to the negative 1. And I have a negative exponent, so that's going to be the reciprocal of 5 to be 1 over 5. And an exponent of 1, I don't need to write a positive 1 down there. So my answer to that is 1/5. Let's look at this example. I have 9 to the negative 2 over 3 to the negative 5th. And these are going to switch. So the negative 9 to the negative 2 is now going to be on the bottom as 9 to the positive 2. 3 to the negative 5th is going to go to the top to be 3 to the positive 5. If I can realize that 9 is the same thing as 3 squared, I can get a matching base number here. I can write that as the 3 to the 5th will stay the same, but 9 is 3 squared. So I'm going to write, instead of 9, I'm going to write 3 squared. And now I'm going to put this exponent of 2 on the outside of that. 3 squared, as we know, is 9 squared. So I just rewrote that just with a different base number. And I've got power of a power here. I'm going to affect the 2 exponents to get 3 to the 4th. So I have 3 to the 5th over 3 to the 4th. Now I've got a common base number, which means I can subtract these exponents. I get 3 to the 5 minus 4, which is 3 to the 1st, or just 3. Okay, let's look at this example. I've got 1/6 times x times the quantity of 3x squared, quantity to the third power. Okay, so I've got to take this exponent on the outside here. This has to affect the 3, the exponent on the 3, which is a 1, okay? And I'm going to affect the exponent on the x. So I'm going to write my 1/6 times x. Well, 3 to the third power, and x to the, remember we're multiplying these, 2 times 3 is 6, so x to the 6th power. Now, I can use the commutative property of multiplication to kind of rearrange the order of these and group the numbers, group the variables. So I'm going to write 1/6 times 3 to the third times x to the 6th. So my exponent on x is a 1. These are 2 base numbers with exponents. They're being multiplied times each other. I'm going to add these exponents. So remember, I'm not distributing that 6 into parentheses, therefore I'm just adding the exponents. Up here, when I had to distribute that 2 into the exponent, then I multiplied them to get the 4. Here, there's no distribution coming out from the coming in from an outside of the parentheses, so I'm adding those to x to the 7th. So I get 3 to the third over 6, not equals, but times x to the 7th. Now 6 is 3 times 2, but we cannot write that as 3 to some exponent. That doesn't work. So there's nothing really I could do here at the moment unless I write 2 times 3, and then I can cancel out one of the 3's up here because I have 3 to the first power. So that is going to be, if I take this part of it right here, that's like 3 to the 3 minus 1 over the 2, and then times x to the 7th, and 3 minus 1 is 2, so 3 squared, or 9, over 2 times x to the 7th. And that would be my answer to that problem. Okay, let's look at this example. I've got negative 2 times z squared in parentheses to the negative fifth, and then z to the 10th over here by itself. So let's look at what we need to do here. This negative 5 needs to go over here and affect the exponent on negative 2, which is a 1. And negative 5 is also going to affect the exponent on the z. So I'm going to have negative 2, and it's going to be to the negative fifth power. And then I have z to the negative 10, and I have z to the positive 10. These are both negative exponents, so I'm going to take those. I'm going to create my own fraction because I've got this positive exponent over here that's going to stay on the top. Both of these are going to go down to the denominator of this fraction that I've created. So I'm going to get z to the 10th over negative 2 to the 5th times z to the 10th. Well, z to the 10th over z to the 10th is like having 5 over 5 to be 1. So I can write 1 over negative 2 to the fifth power, and negative 2 to the fifth power is negative 32. So I get 1 over negative 32, which is just negative 1 over 32. So the fraction has a negative value. This negative does not need to stay on the bottom. Okay, we have this example. Got some negatives in here. It's getting a little bit more complex. I'm going to take these negative exponents and move them. I've got a to the negative 3. That's going to go down. So that's a to the positive 3 on the bottom. This a to the negative fifth is going to go up to be a to the positive fifth on the top. And b to the fourth and b to the fifth are going to stay where they are. Okay, I've got common base values of a. So that's a to the 5 minus 3. And I've got common base values of b. So I have b to the 4 minus 5. Well, 5 minus 3 is 2, so a squared. 4 minus 5 is negative 1, so that's b to the negative 1. Okay, I've got one positive exponent, one negative, so I'm going to create a fraction and move the negative exponent down. So I get a squared over b to the positive 1. For positive 1, I do not need to write a 1, so there's my answer. And now the very complex one. So I'm going to start with this negative exponent on the outside. So that's going to flip everything on the inside. Regardless of what their exponents are, everything just flips. So I'm going to just flip everything upside down. So x2 goes on the top. So all these things on the bottom are going to be now on the top. So y to the third and z to the negative 4. And then on the bottom, I'm going to have x, y to the negative 2 and z to the negative 3. Okay, that now I have a positive 3 on the outside for my exponent. I have to distribute that to every single exponent, both top and bottom. So that's going to be x to the 2 times 3, this 2 times the 3, so 6. Y, the exponent on y is 3 times that 3 out there to be 9. And z, that's a negative 4 times a 3 to get negative 12. On the bottom, I have x to the first. This 3 is going to go down and give me x to the third. I have y to the negative 2. Negative 2 times 3 is negative 6. And this z to the negative 3, the negative 3 times the positive 3 is negative 9. Okay, now I'm going to look at what I have here. I've got some negative exponents. So anything that's got a negative exponent, I'm going to take that y to the negative 6, I'm going to move that up. I'm going to take this z to the negative 12 and move that down. I'm going to take this z to the negative 9 and move that up. The other ones are positive exponents. Those are going to stay the same. So I'm going to rewrite this. X to the 6th, y to the 9th, y to the positive 6, because that went up, z to the 9th. On the bottom, I have x to the 3rd, and that z to the negative 12 went down, so z to the 12th on the bottom. So now I'm going to look at my little groupings here. I've got x to the 6th over x to the 3rd. That's going to give me x to the 6th minus 3. I've got y to the 9th times y to the 6th on the same level of the fraction. So that I'm going to add those exponents, so 9 plus 6. And then I've got z to the 9th over z to the 12th. So that's going to be z to the 9 minus 12. That's 6 minus 3 is 3. So x to the 3rd. 9 plus 6 is 15, so I get y to the 15th. 9 minus 12 is negative 3, so I get z to the negative 3. Got two positive exponents, one negative, so I'm going to create a fraction, and I'm going to move this down. And my final answer is x to the 3rd, y to the 15th, over z to the positive 3 for my final answer. Now, you might notice there's a couple, different things that can be done at the same time or slightly different. That, when I had this 12 in the denominator, 12 minus 9 is positive 3 for the denominator. If I start in the denominator with that positive 12, subtract the 9 from the top, that leaves me 3 in the denominator. So if you're going to subtract the largest number minus the smaller number, just make sure your answer goes where you started. So here I start with the z to the positive 12. I start in the denominator. 12 minus 9 is 3. I write that answer to that problem in the denominator where I started. Okay, and that's the end of day 1.